Okay, afternoon everyone. I've had the privilege of presenting at a couple of these conferences. I presented at the 2014 conference and with Matthew at the 2016 conference, and again today. So today we're going to give an update for the NorthConnex project, which was the main presentation in 2016. We won't be paying out any architects or kissing any babies. So, presenters, myself, Dave Mayers, I'm a surveyor, and Matthew Monk, an engineer. So, as you can see, Matthew's an engineer. I'm a surveyor. I work for the joint venture, Bouygues Lendlease. I'm the survey manager on the project. And I was able to collect the Innovation Award for the project on behalf of the survey team in 2016, which was a very proud moment. As for Matthew Monk, the man here on my left, he's a civil engineer and not a surveyor. He's a contractor, gun for hire. Matt just slipped that one into the presentation. He's highly proficient in tunnel modelling and is data systems and customisation for the NorthConnex project. So let's get right into it. In terms of for those of you who don't know what the project is, NorthConnex is a motorway tunnel, and it joins the M1 to the M2 from Pennant Hills to Wahroonga in Sydney. It's got two main components to it. The NorthConnex project is a project within itself, which involves all of our tunnelling, and we've got a separate project as well, which is the integration for that tunnel onto the M2. So that's 3.5 kilometres worth of roadworks on the M2 under traffic. It's Australia's longest and deepest tunnel, longest and deepest road tunnel, and longer than the Eastern Distributor, M5, and cross-city tunnels altogether. As far as the project goes, we've got the federal government and state government, RMS, our clients Transurban, delivery partners Bouygues and Lendlease. In terms of a geographic location, NorthConnex is in Sydney's northwest, the green part here, which connects up the orbital road to the highway to Newcastle. To give you some fast facts, twin motorway tunnels, 16 kilometres in mainline length, around about 4 kilometres in lengths and ramps, 75 cross passages. Some of these tunnels are longer than those other tunnels mentioned as well. 4 shafts, 210 metres in total depth, but the longest or deepest being 90 metres by itself, so that's quite a deep shaft. 2.25 million cubic metres of excavation material, and 20 road headers, all concurrent, so it's quite a challenge. Looking back on our presentation from 2016, we finished off our presentation with saying, you know, what does the future hold? So these were our targets. Expansion and automation of processes, real-time reporting from the field, if possible, an improvement in the management of data, and our ability to provide data-driven solutions. At the time, there were numerous projects on the horizon. Those projects have come to fruition now, so we're right in the thick of it. In terms of current progress, the project has completed excavation at this point, and then we're moving on to more of a tunnel fit-out stage. 2019 will be the commissioning, with the planned opening at the end of 2019. In general, our progress on the project, we've completed 20 plus kilometres of mainline tunnelling, 2.1 million cubic metres of spoil has been excavated, 680,000 cubic metres of that has been transported to the Hornsby Quarry for remediation. 220,000 cubic metres of shotcrete and concrete. These are just huge figures. The scale of this project is massive. At its peak, roughly 2,000 workers on site. So you can see the scale of this. Just focusing in on the survey team, or survey progress, we've got 60 plus surveyors. Now surveyors aren't easy to come by in the current market, so we've done well to maintain that number and to make them as efficient as possible. Of those 60, we have roughly 12 on our surface works, and we have 50 plus on our tunnelling works across 4 different tunnelling sites. Those surveyors, they produce information. We've had around about 75,000 fieldwork submissions, so 75,000 separate survey submissions, which is a huge number. 5.5 million survey points under management currently, with 3.5 million points being as-built points. Another point of note is our design across all the surfaces in the tunnel is around about 2,000 plus profiles, all separate and different profiles. So in order to get those into a design model to prepare for set out is quite an achievement. This graph shows the total number of fieldwork submissions across our project. In 2016, we knew that there was going to be a problem with data management on the project, and we anticipated that there was a tsunami coming. And as you can see, it came real. It came to fruition. What we've got up the right-hand side there is all the different sub-projects, okay? So they're all roughly the same according to their size and scale, and you know, there's just a massive number there for us to manage. It doesn't manage itself. As far as synergy goes, we implemented synergy in 2015 as a data management solution for the project. And we just had the one server then, that was sufficient, but as the project grew and grew, we soon found that we needed, immediacy of the data was a problem, download speeds, not through any fault of our own, but external network matters. So we installed a file replication server on each of our 4 main tunnel sites. So we had the main server in our main office and 4 replication servers out on site, and that largely fixed our problem. A few more facts for you guys. We've got 880,000 files within the system, 1.6 million file changes. Total size of all our changes, 3.9 terabytes. These massive numbers, big data sets. As far as our project size goes, our distributable information to the sites, 9.3 gigs as a data set. So we're dealing with big data sets here. I'm now going to pass over to Matt to detail a few new items that we've got been working on, and we either implemented or about to implement on the project. Thanks.
Okay, thanks, Dave. So, what's been new since 2016? We've done a lot of work customising reporting, so just little macros to make people's life easier. So ovalisation, which I'll cover in a bit more detail later. Drainage and pits, so automatic labelling for as-built plots and so on. Niches, which is just little cutouts into the tunnel wall. All those sorts of little, fairly easy things, but they're done hundreds of times, so anything we can do to help is welcome. We also have a macro called Kronos Live. Kronos is our monitoring database. It's like a GIS-based. So we actually have a macro that we can connect live to this database, and you can download some monitoring points based on, a polygon or date ranges. So that's really useful rather than having to distribute the whole data set at once. Auto plotting, which I'll cover in a bit more detail. Same with the attributes database, and also some synergy customization to really help all that data flow through our workflow. So auto plotting, Sam Check had a bit of help on this one, so thanks Sam. And basically it was a way to automate and standardise the PDF plots from our survey data. Okay, so using things just fairly standard PPFs and preset plot frames, we can automate a lot of this. You know, we've got different types, whether it's a sketch, so an informal submission, or a formal plot and different title blocks and so on. We actually have a drawing register. It's not the one built into the PPF for various reasons, but it also allows us to do things like uprev issues and just work better across our project. Also, importantly, automatic naming of outputs. So every report has a particular name, and from that we can use the synergy customizations to automatically apply attributes, automatically move them to folders, and also push that data out so people like the engineers and managers can then look at those reports. So that's all about streamlining that whole workflow. Ovalisation. Basically it's about ensuring the tunnel is a nice shape. A bit more complex than that, but that's the gist of it. There's actually multiple criteria we have to meet. There's a minimum thickness for the tunnel support, so it doesn't collapse. Tights, so you can't encroach upon that trafficable area. And you also have to do relative checks, so relative to all the other points across the profile. So this is a natural extension of our heat maps that we showed at the last conference, except this time it's grid-based and a bit of averaging going on. And we also generate points, so there's a plot side to it, which you can hand to an engineer. But then there's also a set out points, which is just 3D points automatically in real world that the surveyors can set out right there and there. So here's an example plot. So these are little grids, and these numbers up here say how much shotcrete you're meant to apply to get it to meet these criteria. So you can see there's a few there, 25 up to 225. So that's the before. So the engineers and the work crews take these, and then they do the remediation work, and that's what you get. So that's a good example of the same section of tunnel before and after. Now, attributes. The problem, right. We love attributes. We use them extensively. We love everything about them, but we have 12D field attributes on every single vertex. And that results in large as-built models. So as a typical 500 metre section of just rock, so just the rock, we'd have about 2,000 strings, 30,000 points, 10 million attributes. Okay, so that's one 500 metre section. We've got 20 kilometres of tunnel. So that's 500 meg just for that one .model file on disk. This obviously impacts the loading and transfers. Okay, disk space on these tablets, the memory, trying to load it and view it, and also the bandwidth just across to these sites and within each site. So here's an example project we have, 8.2 gigabyte, 65,000 elements, almost 1 million points, and that takes about 30 minutes to download. That's in the office, so the sites will be even worse. So, how do we fix this? We export the attributes to files on the server. Okay? Originally planned to store them in an SQL database. Still might, but for now, we just store them on disk in files. Okay? We replace these attributes with a link to that file. Okay? We could have just deleted them, but we actually want them. We want to use them, and once you delete them, you can't get them back. So, we also detect duplicates, so a lot of the information is the same, not just on the string, but across the whole data set. You know, your helmet resection might be the same information, you know, the product version. So detection of those duplicates as well. So we can still inquire and access all these attributes, because we can just look up that file name and retrieve that from the file. And the project size was reduced significantly. So we started off with 8.2 gig, and we got that down to 1.3 gig. So that's over 80% reduction there. So down from 13 to 2 minutes to download, creates about 2 million files, 5 million duplicates were skipped, and that's 180 million attributes. That was just one project on our master survey model. So yeah, we'll continue to push that out, I think, and get those benefits from reducing that size. 80%, I think you can see. Big help there. So the lessons learnt on this project. Have a clear strategy and stick to it, or change it as needed. It's construction. Things change all the time. You might think you got it planned out, but no. Get your data management systems, Synergy, in place ASAP. We knew back then when we had less than 5,000 files, and now we're 75,000 files just on the survey. So get those in place ASAP. Focus on your pain points, so plotting. I don't think anyone really likes plotting. There's a lot of plots and it's always painful, so streamlining that. And of course, be flexible. Things change, and unfortunately, often at the last minute. So what are some improvements? Definitely better training of our users. We've been a bit poor on that. Clearer identification of reporting requirements, what's required, how it should be presented, smaller, more manageable data sets. Yep, lesson learnt. And more and better use of the digital model. So for example, using this information that we've got and sharing it with other groups and users. So whether it's 12D view or web or a GIS system, we're not sure. So I'll pass back to Dave for the conclusion.
Okay, thanks, mate. That's great. Okay, so in conclusion, NorthConnex and 12D, fantastic partnership. I remember speaking to Lee and Alan when we first won the project. We just said to them, look, we've got a number of problems and can you help? And they responded. So we've had great success. And so thank you for that. The conference theme in 2016 was mining the data. And of course, the forum theme in 2018 is pushing the boundaries. And I think we can demonstrate that we've done both of those on the NorthConnex project. As far as 12D model goes, after much consideration, yeah, it's the only software that allows us to do what we need to do. Speaking from a survey point of view, yeah, the scale of this project, being able to consume information from our master models and produce information and then finds its way back, pathway back to, other groups is amazing. It's a building block for a more digital future. Synergy, it's been really good for our project. As Matt said before, it's been a godsend as far as security of our information goes. In surveying circles, security of data is paramount. So that's been a great initiative for the project. Scalable, reliable, it's worked very well, and flexible as well. So the future, looking towards the future, we've been awarded a new project in WestConnex, a new stage. Now this is joint venture partners, the two that are already on NorthConnex, plus joint venture partner here, Samsung. And also, as far as design goes, Oricon and Jacobs formed a joint venture for the project as well. So our hope is that this will be the best project ever. BIM++, that might be the future, whatever that means. It means something, but we don't know what it means. I'll tell you in 2 years. And of course, like NorthConnex is a building block for that. We've proven theories, methods of work, they work for us, scalable, and they're correct. So we're using NorthConnex as a springboard, if you like, for future projects. We are, however, always constantly challenging ourselves for improvements to our processes, as you can tell by Matt's delivery. Now look, I'm just going to finish off by showing you some really cool photos from the project. They're in a rough sequence of events on how they go, I guess, how the project's constructed. So I'll talk you through some of them. NorthConnex is a road header tunnel, excavated with road header, if you've never seen one before. This is one at work. This one's name is Dahlia. They've all got various names. That's actually the daughter's name of the project manager out there. This is a photo of the Hornsby Quarry that's being filled with that 860,000 cubic metres to remediate the Hornsby Quarry, which is a bit of an eyesore for the area. So hopefully we can do some good there. This next shot, it's a brilliant shot. This is some rock bolts being inserted. Okay, and you can see the poor little fellow down here doing his job. That's a surveyor. He's involved in almost every aspect of this project. Application of shotcrete. Okay, shotcrete spraying. Just vast amounts of shotcrete on the project. This is some sprayed waterproof membrane going on over the shotcrete. That's hand sprayed from an EWP, that one. This is preparation for our cast in situ lining pours. Okay, so this will be actually I think the next shot there, that's the finished product. Okay, so that's in shallow cover areas, I guess, where we don't do the shotcrete spraying, we do this instead. There's another shot. This is a diamond blade that we're using to excavate some of our drainage and LV installations. As you can see, these run the stretch of the tunnel, so there's quite a lot of work just in that activity. Here's another shot of the tunnel, completed at this point, and you can see there's delineation there for our workers and etc. Ventilation bag through the middle. Again, same sort of shot. And this is one of our portals, breakthrough at one of our portals, which is, as a surveyor, is very, happy to see all these breakthroughs happening at the right areas and at the right times. And so, further info, anyone who has any questions, please come and see either Matthew or myself. We're here for the whole conference. Don't be shy. Happy to answer all your questions. And okay, thank you all for your attention.